Hello and welcome to Online Math 1332. Today's section is section 11.3, combinations. Before I go ahead, I always make sure you guys have your pen and paper ready, you have your worksheet ready. Now let's go ahead and start. A combination of items occurs when an item is selected from the same group, it's not used more than once, and the order makes no difference. Unlike permutation. Permutations involve situation where order does make difference. And combinations, the order does not make a difference. So let's go ahead and see the difference between permutations and combinations. So for the first two examples, you are not solving the problems. You're just telling me, is that a permutation or is that a combination? Okay? So let's go ahead and see this one. Determine which involves a permutation and which involves a combination. 6 students are running for president, vice president, and a treasurer. So now, as soon as you hear the words president, vice president, treasurer, you're going to go back and think, does it make a difference if one is the president? That's an arrangement. So I could be the vice president, you could be the president, and somebody else could be the treasurer. That's one arrangement. I could be the treasurer, you could be the president, somebody else is a vice president. That's a different arrangement, right? So when the order does matter, it becomes a permutation. Now let's go ahead and read the next step of the problem. The student with the number of votes becomes the president. The second highest becomes the vice president. The third highest becomes a treasurer. Now what I want you to do is tell me, is this a permutation or a combination? Remember, I'm going to go ahead and draw different people. So, change the color, change the color, Okay, so this is one. So the first one is the president, the second one is the vice president, third one is the treasurer. Now, if the same person, this treasurer, now if he becomes a president, that's a different arrangement. Do you see that? If this person becomes a president, that's a different arrangement. So when the arrangement does matter, it becomes a permutation. So it's a permutation. Now let's go ahead and see an example for a combination. How does a combination look? 6 people are on the board for supervisors for your neighborhood park. Okay, so there are 6 people. I'm going to change the color. 6 people. And a 3-person committee is needed. Now, I want to pause here and ask you, they just told me that they want a 3-person committee. The 3 people don't have any cadres. It's not like president, vice president, or treasurer. They're just 3 people together. So does it matter which 3 people they pick? No, it does not. So usually the words like committee, where it doesn't matter who's who, they're all the same, but they're just picking 3 of them. When you have something like this and the order does not matter, it's by default a combination. So I'm just not calculating it. I'm just telling you it's a combination. Combination, because I am just picking 3 people. So how does that look like? So 1, 2, 3. I have 6 people here. 1, right? How many did I draw right now? Oh, it's still 5. So what I'm doing is I'm picking some 3 people. So I'm just picking 3 people. Do you see that? Oh, I picked this hand too. I'm just picking, never mind, I picked the heads. So I'm picking 3 people, right? When I pick these 3 people, does it matter who do I pick first, or who do I pick second, or who do I pick third? No, it's all the same thing, right? Because I'm just picking 3 of them, so order does not matter. Okay? Now let's go ahead and see what exactly does it mean by a combination. Comparing combinations and permutation. So you have, A, B, C. So I want you all to look here, and I want you all to tell me what's the difference between a permutation and a combination. So if I see ABC, that's an order. ACB, that's an order. Different order. So here BAC, BCA, CAB, CBA. You see, all these are different orders. This is order 1, order 2, order 3, order 4, 5, and 6. Different orders. But what 3 letters am I using? I'm simply using ABC. That's a combination. Do you see that? Again, in here, I'm using ABD, ADB, BAD, BDA, DAB, DBA. These are all different arrangements. So these are my permutations. But what's the combination I'm using? I'm using 3 letters ABD. Okay? So how to calculate the formula for combinations is you represent combinations with a C and permutations with a P. So when you write NCR, your NCR is simply your n factorial divided by n minus r times r factorial. When it's a combination, that's a formula for combination. So this will make more sense when we go ahead and plug it into the formula. How many 3-person committee? So every time you see the word committee, it's a combination because it doesn't matter who is who. It's just a committee of 3 people where all 3 people are equal. So I am forming a committee. I'm forming a 3-people committee from 8 people. Again, it's a committee, so it's a combination, 8C3. Okay? So what I want you all to do is I want you all to open up your Desmos, and we're going to go ahead and see this in the Desmos calculator. Actually, I want to go ahead and open Desmos here, right here. So you go to your functions, NCR. Remember, it's a combination. So how many am I picking? I am picking from 8, 3. Is that what it was? Yeah, I'm picking 3 members from 8 members. So NCR is 8, 3, which is 56. So I'm going to show you the mathematical way of this as well, 56. So when I plug into the formula, it is 8 factorial. Remember, it's n factorial. So this is my n, this is my n, and this is my r. So 8 factorial over 8 minus 3 factorial times 3 factorial. Right? So that's the formula, n minus r times r. So when I go ahead and plug this in, I have 8 factorial over 8 minus 3 is 5 factorial times 3 factorial. I'm going to expand this. Remember, you all don't have to do this. 8 times 7 times 6 times 5 times 4, 3, 2, 1. Divided by 5 factorial is 5, 4, 3, 2, 1. 3 factorial is 3, 2, 1. So 5, 5, 5 cancel, 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 cancel. I will end up with a 56. I don't want you all to do this manually. I want you all to plug it into your Desmos. Okay? All right, let's try the next one. An election ballot asks voters to select 2 city commissioners. So it's saying, hey guys, just pick any 2 city commissioners from a group of 6 candidates. So both of them are commissioners. Both of them are equal. So the order does not matter, right? When the order does not matter, you know it's a combination C. So let's go ahead and see. From 6, I am picking 2. There are 2 commissioners. Did they tell you one is higher than the other? No, it's just simply 2. Both of them are equal. So it's a combination. 6C2. How do you plug that into your Desmos? I'm going to clear this. Function, NCR, right? Because it's a combination. 6, 2. Remember, always the bigger number goes first. So 6C2 is 15. Okay? So the answer to this one is 15. All right, let's see what we have next. Of 19 possible books, you plan to take 5 on your vacation. How many different collections of 5 books can you take? So does the order matter? Like I take this book first. Okay, let me go ahead and simply draw something. So you have all these books here, right? All these books here. You plan to take 5 books. Does it matter which 5 books you take? So if you take these 5 books, those are not 5. Okay, let's say you take 1, 2, 3, yeah, these 5 books. You take these 5 books. Does it matter if you take this book first or this book? Because you're taking all of them to your vacation, right? You're taking everything to your vacation. So does it matter which book you take first? No, it does not, right? So it does not matter which book you take in first. So what are you doing here? You are from 19, you're choosing 5. Does the order matter? No, I'm just picking 5 books and I'm going to take those 5 books. Do you see that? Okay, how do I do that? 19C5. Again, clear. Function. NCR. Go back to main. 19, comma, 5. Always the bigger number goes first. So I get 11,628. So my answer is 11,628 ways I can take any 5 books. Remember, if they ask you which book do you read, then that makes a difference. But you just pick in some 5 books and all 5 books are equal to you. Let's check the next one. You volunteer to help drive children at a charity event to the zoo, but you can fit only 6 out of 18 children in your van. How many different groups of 6 children can you drive? So you have all these 18 kids and you're trying to take them in a big van, right? So from 18, you are picking 6. Now, you're just taking 6 kids and taking them in a van. So if the first kid goes first, the second kid goes, the order does not matter. It's just a group of 6 kids that you're taking. So when the order does not matter, it is your combination. 18C6. So you go to your function. Let me clear this. Function, NCR, main, 18, bigger number goes first, comma, 6. It's 18,564. So how many ways can I do that? 18,564 ways. Okay? All right, let's see what we have. And here they said, use the formula. They're asking you to find 31C2. So they said find 31C2. I'm going to go ahead and plug that in my Desmos. Clear all, function, NCR, main, 31, comma, 2. 465. So what do I get? 465. Let's try the next one. Use the formula 9C4. So again, Desmos, clear all, function, NCR, 9, comma, 4. 126. 126. Let's see. Okay, that should bring us to the end of chapter 11.3. Again, go ahead, complete your homeworks. If you have any questions, don't hesitate to email me.